Okay, next we move on to auto-oxidation. So what is auto-oxidation? It's actually undesirable chemical reaction which involve oxygen that will degrade the quality of an oil. The undesirable is caused by the formation of secondary products. So before formation of secondary products, it started off with formation of primary products, which followed by its decomposition to secondary product, and then this secondary product will leads to formation of tertiary product. Okay, the secondary products are the one that is responsible for the undesirable food, undesirable reaction to food, which is termed rancidity, which is actually referring to oxidative deterioration. Now, the autooxidation are divided into three parts, which are initiation, propagation, and termination. So, what leads to autooxidation or lipid oxidation to lipid containing food? It's the major reactant are the unsaturated fatty acid. Remember, I have covered the physical properties between saturated and unsaturated. So when there are more double bond presence, it becomes more unstable to oxidation or heat. Okay, so the more double bonds that are present, the susceptible it is to lipid oxidation. So if we see in this table here, okay, the energy needed to remove hydrogen, okay, in saturated compared to unsaturated with high number of double bond is higher. Okay, for example here, it needed 100 kilocalorie for every mole to remove hydrogen. Okay, this hydrogen here. Whereas in unsaturated fatty acid having two double bond here, the removal of this hydrogen is easier. Okay, it need less energy, which is only 65 kilocalorie per mole. So let us look at the mechanism for lipid oxidation or autooxidation. So it will initiate when the hydrogen atom at the methylene group in double bond of unsaturated fatty acid is removed. Okay, so you have the unsaturated fatty acid here. Okay, the hydrogen is removed. Okay, at the methylene group. Okay, in the double bond, it will form alkyl radical. Okay, alkyl radical here as well as hydrogen radical. Now, how does this formation of radical initiate? It's initiated by enzyme called lipoxygenase. Okay, so in order to prevent the initiation of lipid oxidation, then we have to remove this enzyme. So how to remove this? By short heating. Okay, because enzymes are very sensitive to heat, so we can inactivate this enzyme by heating. Besides enzyme, another factor that can initiate lipid oxidation is the presence of metal ion. For example, iron, cobalt, copper. And these metal ions are found naturally in food, which are actually from metal equipment used during the food processing. So, to prevent the initiation of lipid oxidation by metal ion, we can chelate um, um, this metal ion using chelating agent such as EDTA or citric acid. Now, when once the lipid oxidation has been initiated, it will propagate. Okay, the free radical that has been formed during the initiation process will combine with oxygen from the surrounding to form a peroxy free radical. And these peroxy free radical can abstract hydrogen from another unsaturated molecule, which would also yield which will yield a peroxide and also a new radical. Okay, and this new radical will combine with oxygen to form another peroxy free radical, and this reaction will be repeated up to several thousand times. Okay, so we consider this as chain reaction. Okay, and this chain reaction will only terminate when they meet with another free radical. Okay, so this is the mechanism of propagation. During the initiation process, free radical is formed, and that free radical form will combine with oxygen from the surrounding, forming a peroxy free radical, and this peroxy free radical will abstract hydrogen from another unsaturated fatty acid to form peroxide and a new free radical, and this will continuous continue okay as chain reaction, okay, forming another free radical and so on. Okay, so the hydroperoxide that is formed in the propagation step just now are named as primary oxidation product. And these primary oxidation products are unstable, so they decompose into secondary oxidation product. Secondary oxidation products include carbonyl, aldehyde, okay, and which are responsible for the rancidity of food. Okay. So the secondary oxidation product, one of it is aldehyde, are themselves oxidize and forming fatty acid, and these fatty acids are considered as the tertiary oxidation products. The propagation will only terminate once the free radical meets with one another. For example, here the alkyl radical meet with another alkyl radical, or the alkyl radical meet with peroxy free radical, or between the peroxy free radicals. So this is the summary of the autooxidation mechanism. So we started off with unsaturated fatty acid. When it is initiate in the presence of enzyme or metal ion, okay, it will form alkyl radical, okay, and this alkyl radical will propagate in the presence of oxygen from the surrounding to form lipid peroxy radical, and then it will combine with another unsaturated fatty acid, okay, by the abstraction of hydrogen atom to form peroxide. Now, the formation of free radical stabilized by resonance. For example, here, okay, the abstraction of hydrogen to form free radical can be from carbon 1 or carbon 3. Okay, this is one example, 9-octadecenoic acid. Okay, so the formation of a radical can be at carbon 8 or carbon 11. Okay, 8 or 11. Okay, it's always next to the carbon having double bond. So this will result in two pairs of resonant hybrids. So these are the resonant hybrids. Okay, if the abstraction of hydrogen is from carbon 8, then you have two this set here. Okay, if the hydrogen abstraction is from carbon 11, then you get this set here. Okay, so therefore there are a total of 4 isomeric hydroperoxide. Another example is autooxidation of linoleic acid, systematic name 9,12-octadecadienoic acid. So this will result in the formation of 3 isomeric hydroperoxide. And of all these 3, okay, the conjugated one will occur in the greatest quantity due to its more stable formation. Okay, so this is the 3 resonant. Of all the 3 resonant, the one in conjugated form is will have highest quantity compared to the other 2. Okay, next we look at the composition of hydroperoxide to alkoxy and hydroxy free radical. Okay, so we have the hydroperoxide here, okay, decomposed into alkoxy and also hydroxy free radical. And this alkoxy radical can react to form aldehyde and also alkyl radical. This aldehyde that is formed can be a short chain volatile compound, or it can be attached to the glyceride part of the molecule. In this case, the compound is non-volatile. The volatile aldehyde are the one responsible for the oxidized flavor of fat, which result in rancidity. So this alkoxy radical can also abstract hydrogen from another molecule to yield alcohol and a new free radical, and this can propagate, okay, through chain reaction until it terminates. Okay, so this shows the alkoxy free radical abstract another hydrogen from another molecule, another fatty acid, which in turn will form alcohol and also a new radical, and this radical will propagate, okay, through chain reaction. So some of the free radical may interact with each other, which in turn will terminate the chain, and once termination occur, it leads to the formation of ketone. Okay, so we have the alkoxy free radical here, okay, meets with another radical, okay, to form ketone. Okay, so once ketone is formed, the propagation terminate. So this table here shows the formation of aldehyde from the breakdown of hydroperoxide from several oxidized fatty acids. Okay, so these are the fatty acids here, and the methylene group involved in the breakdown, and these are the isomer of the hydroperoxide form. Okay, and these are the aldehyde formed from the decomposition of this hydroperoxide here. Okay, this graph shows the peroxide formation and its decomposition as a function of time. So during the induction period where the free radical is initiated, the peroxide value is 0. As it propagate, okay, over time, the peroxide value will increase, okay, because it's being formed, okay, during the propagation phase, until at one point it stabilizes during the termination phase, okay, where the radical meets with another radical, and then once it terminates, of course the peroxide value will decrease, okay, and this is the decomposition phase. So a combined index of primary and secondary oxidation product will gives a better evaluation of the state of the oxidation of a particular oil, and this is expressed as Totox value. Totox value means total oxidation value. So this is the formula. Totox value is 2 times peroxide value plus anisidine value. Okay, so 2 times PV plus AV. So AV is a measure of the secondary oxidation product, in this case aldehyde. So primary, the PV value is mainly from the hydroperoxide. Okay, so the lower the PV, the better the quality of oil, because when the PV is low, means the likelihood of formation of aldehyde, okay, AV, would be low also, because this is the one that determine the formation of secondary product, because the PV value will leads to formation of aldehyde, okay, the AV value. So most customer will require PV value less than 10 for marine oil. So the best is PV value is as low as 2. So next is the antecedent value. The AV value is depending on the decomposition of the PV hydroperoxide. So the hydroperoxide decomposed to form carbonyl and also aldehyde specifically. So this is the one that responsible to the rancidity of oil. Okay, undesirable rancid smell. So therefore, the lower the AV value, the better the quality of oil. How to get low AV value? Low PV value. Okay. So most customer will require AV value less than 30 in marine oil, but it need to be as low as 10. So the lower the Totox value, the better the quality of oil. So this green curve shows the Totox value. This purple curve is the PV value, and this red curve is the AV value. So the formula is Totox value is 2 times PV plus AV. So if the PV is high, AV also would increase. So when PV high, AV increase, the Totox value would be high also. Okay, so that's why low Totox value means better quality, because if these two are high, means high aldehyde compound, which leads to rancidity.